Alright guys, let's see, this first one is exactly like the one we just did a minute ago, so you gotta underline for yourself. It's common. So that means that the 2y plus 3, I can take it out, and then we're gonna left with the stuff on the outside there.
Would it be the same thing if like the...
Yeah, you can, so if you wrote this instead,
I was meaning like if the xy, it had a subtraction sign and the other one was positive.
oh, if this was minus and that was plus,
Yeah.
then you can't do shit.
Oh.
You can't factor it at least,
Oh.
because then they wouldn't have anything in common.
Oh.
Yes.
I did not put the swoops around the 2y plus 3. I just took that out like we were
Now,
doing in the previous
if you,
example.
no, I never did that. Never. I want you to really, really be careful.
Which one?
That makes it different.
Totally
okay,
does.
'cause- I
The
see.
difference between this and this is huge.
You factor the 3.
And this one, what's multiplying by 4x was 9. This whole thing. On this one, what's multiplying by 4x was 9.
3.
Just 3.
Okay.
Okay. If I want this whole thing to go through, I've got to put it in parentheses. So it becomes one thing, and it just can go through. Now, what's a little bit different than number 2 here?
You have to pull it, sorry.
Yeah, not only do you have to worry about this dude, but it just now just becomes a normal GCF problem. That's just another thing to think about. So what number comes out?
Yeah, 7m.
More than that?
7
2, right?
d plus
Greatest
3
common
is
factor.
D plus.
14 comes out.
Oh.
If you took a 7, notice how you have a 4 and a 2?
Yeah.
Well, they still have a 2 in common, so you can still take another thing out. So you don't have to take the biggest thing out at first. You just have to look through where you end up and make sure there isn't still something else you can do. You're not done then. Does that make sense?
Yes.
If I said factor 18 completely and you say 3 times 6, I'm going to be, I keep going. Right? The 6 still has a way you can break it down. So the greatest common factor. And then m's, how many m's? 1 m. And then how many d plus 3 c's? 1. And then what's left?
2.
2
M squared.
m squared. That's gone. I like it. Minus. Beautiful. 14 divided by 14, m divided by m, d plus 3 divided by d plus 3. This is 1.
There we go.
Let me let that soak in.
Yeah, I was thinking that what do I do with the end?
Alright. So I think we're ready for the next level. The whole idea of factoring is you're just going to keep going to the kind of the next level. GCF, I call it the 0 level because you always try GCF. It might be the only thing you can do, or it's the first step to make the rest of it easier to do. So you always try GCF first. So here's the next level. Whole Nova level. All right, Jeff, you can do it. Can you?
Yeah.
First off, are there any like terms up there? No, good. So don't do that. I love it how people escape factoring by just pretending you can add all those together. So then there's nothing to factor. Very good, Jeff. You know like terms are there. Now, here's the thing. This is one step away from what we were doing here. How many terms are up there? So every time you have 4 or more terms, you try to do what we're about to do. So I have a little handout that I'm going to give you in a bit that's got, this side, look at that sign, holy shit. But at the very top is kind of a summary. So we're going to learn, when you got 4 terms, you do this. When you got 3 terms, you try these things. When you got 2 terms, you try these things. So the number of terms tells you what to try. That's nice. Math doesn't normally do that for us. So when I have 4 or more terms, you do what's called grouping. You group them up. Is there something that comes out of everything? No. So you always try GCF first, because that would make the number small. That would be nice. But nothing comes out of everything. Like the 27 kind of throws everything off. So then you try to group it. And now you look at it like a little GCF problem. There's two little GCF problems I just underlined. What comes out of these two?
4.
4. And
X.
X. Yeah, so this will be 2y plus 3. Some of you guys might understand where I got this problem from. Plus, what comes out of these two? 9. 2y plus 3. How do I know I'm on the right track? Because these two are the same. If they're not the same, either it's not factorable, or you made a mistake, or you got to switch the middle terms around because they put it in an order that they just didn't go together. So that is a possibility. When you have more than four or more terms, you might have to switch them around to make it actually match up, to make it work. This one worked. One more step, and do you guys see? I mean, that's this. It's this problem. All I did was distribute the 4x and distribute the 9s. And what did we just do? The first step we did was undistribute that, and then we said, oh shit, these are the same. I can go one more step. Take the 2y plus 3 out, and you're left with 4x plus 9, just like we did here. Exactly the same thing. So you can see why we call it grouping, because the first step is to group parts of the problem and then attack those parts by themselves. And hope to God they have something in common after that. Yes, ma'am?
What if the number, like, what if 27 was for 12
Beautiful.
x's?
That's what I'm saying. You might have to switch things around to make it work.
You can do that?
Totally, of course. This is addition. Even if it was subtraction, as long as you bring a sign with it, it's commutative. Right? So you can change the order of what you add. Yeah. Alright. Let's try another one. When I throw negatives in there, that also messes things up a bit. Let's see if I can make one up. These are the ones that I have to be careful about. Let's see. You can do it, Jeff. Well, we'll find out. Yeah, let's do it. Let's just keep it simple. That's a good idea. Oh yeah, let's do it. Yeah, that's probably good. Let's see if Jeff made one that works. We'll find out. All right, sure. Now, if you've been taught this before, they might have told you to put parentheses. That's stupid. That's some stupid shit. Because if you put parentheses here, you effectively took a negative out. You got to change the sign. That's a lot to freaking remember. So don't draw parentheses. That's stupid. Group things like this. Those two and those two. And again, why am I doing this? Well, first off, does anything come out of everything? No. That M screws that up, right? It's got no chance. Are there any like terms? No. There are 4 terms, so I know to try group. What comes out of these two? 3AB, I like it. So what's left here? 3A minus 1, I like it. Got to put the minus 1 because that divided by that is 1. Now, here's where the negative can really screw you up. Now, does anybody realize, once I get this set, in order for it to work, this has got to be the same thing, right? So this is a clue. I need a 3A here. Well, if I just take out an M, I'm going to have negative 3A. So what do I have to take out to make it become 3A? A negative M. And does that come out of here? Yes. So the negatives cancel, the M goes away, you get 3A, and M divided by negative M.
What negatives cancel?
Because you took it out.
Nothing. But you have to put a 1.
Negative divided by negative is positive. M divided by M, there's just a 1 here, so I don't even write it.
So negative 1?
What is m divided by negative m minus 1? Are these the same? Yes.
Well, I feel positive.
Oh, all right, good. Well, not good, but real quickly. Again, as soon as you get that written down, put your pencils down for a minute, or just promise me you're not going to write this. The big mistake is somebody does this, and then somehow they keep going, and they just kind of smoosh. I'm going to put that there, and oh yeah, I'm going to put that there too. That doesn't make any damn sense at all. Doesn't make any sense. What did you use to get from here to here? You didn't factor anything out because they don't have anything in common. You just kind of like threw everything down there and prayed, right? Or maybe that's what you thought I was doing over there, which is completely wrong. What was I doing here? These are the same. It can come out. Do I see anything the same here? No. It doesn't mean that it's not doable. More than likely, it means I made a mistake. I forgot to change the sign. Now these are the same. So now I can take 3a minus 1 out. And I'm left with 3ab minus m. So again, you see how it goes. That times that is there. That times that is there. I'm just undoing that now. So yeah, factoring is a little more difficult because we're doing things backwards. Whew. I like it. So you guys try these two. To be safe, I'm just going to take some from the book. There we go. Ooh, I like that. They can be some pretty easy ones. Oh, well, that's fine. So sorry. I did. you guys, let me catch up to you here. So both of these, real quick, have 4 terms. They have nothing that I can take out of everybody. Right? So I just go ahead and try to group it. If the grouping doesn't work, I make sure I didn't make like a negative mistake. And if I didn't, then I try to switch the middle terms. Normally is what's the trouble. So what comes out of these two?
X.
Good. I can take 2 x's out. So here I'm going to have an x left, and here, of course, I'll have that 1 that seems to keep popping up. And then out of here, I can take 2. I'm left with x minus 1, and that tells me I'm on the right track. So I can take that x minus 1 out, and I'm left with x squared plus 2. So this one, same idea. It's got that negative in the middle, of course, that you got to be careful about. So what comes out of here?
X squared.
Good. I can take the 2 x's out like it just did up here, and there's this little m dude that's just kind of extra.
3x.
Good. We got that 3 left, 1x left, and then that 2 is still left. I took all this out. Boom. Now you don't have to do. You can just look at this like another problem, but this is a clue. A clue. To make this become 3x, I've got to take out negative 4. And I don't want a b, so I've got to take a b out. Thankfully, that comes out of this too. So then I will be left with 3x. And then 8b divided by negative 4b is negative 2. B's cancel. 8 divided by negative 4, negative 2. And then I know I'm on the right track. 3x minus 2.
X squared minus 4b.
Golly. I like that thing we got.
I switched to negative 2 x squared and x raised to 12.
Oh, you turn these around?
Yeah, I switched them.
Okay, cool. I love it. Did you get the same answer?
Now I got it the other way around so that.
No. And again, it's the same answer. This is the same exact answer. Right? If I said factor 14 and somebody said 2 times 7 and somebody else said 7 times 2, then I'm right. No, I'm right. They're both right. So real quick, what happened to you though, Carlos? Can you tell me, like, right here, what's here for you?
X squared and.
No. That's there. That's what's there for me. What's there for you? If you turn these around,
Oh, okay.
right? Okay. Well, all right. I was so excited for a second. If you turn those middle terms around, the middle terms. Let's see what happens. So here I can take a 3x out, and then I'll be left with x squared m minus 4b. Here I can take out a negative 2. That's it. So then I'll be left with x squared m minus 4b. Do you see how that is on the outside, whereas for us it was on the inside? That's on the inside, whereas for us it was on the outside. But don't we still end up at the same place? We both got this times this. I like it. And that's going to come into play in a certain form that we're going to do later. I think I'm not going to give this to you yet. We're going to do this tomorrow. So on the back I've got this kind of like self-discovery handout that I want you guys that I created. That sounds exciting.
I'm on my last page.
Really? All right. That's plenty.
You probably help me do how you got